So we're advancing in the countermeasures, and we're up to module 11H now, and we're going to talk about the decision matrix. Now, on the C4 worksheet, this is what this decision matrix looks like. Um, I'm constantly learning new things and constantly trying new things, so this may not always work out to be the best. So the way this table works, and the way I learned it way back in the Army 100 years ago, we're going to put our countermeasures in the column to the left. Countermeasure 1, countermeasure 2, countermeasure 3, countermeasure 4. We're going to put our evaluation factors across the top, and we're going to put our scores across here, and then we run the math. But after playing around with this for a little bit, I decided I was gonna turn it on its side. So I did a little pivot stuff to match the layout of these to make it easier to transfer the scores we got from our 5 trials to the decision matrix itself, so we can fill out pretty quick. So here's what that matrix looks like. So we're going to take each one of the score boxes and transfer the data from the current column into the raw column on this particular matrix. And we'll do that with every one of the countermeasures across the board. The next step is to normalize. Well, what does this mean? Okay, so we're going to kind of make it easier to do the math. So instead of doing the math where we're going to weight the 1,784 and the 1,986 pounds, what we're going to do is we're going to say among these 5, whichever the one is best gets a highest score, right? So if there's one that's clearly better than everything else, it's going to get a 5. The one that's the very worst, it's going to get a 1. Now, if they're all kind of similar and clustered, you can have a bunch of 2s, 3s, and 4s, but we want to try to score these that gets us as close to actually reflecting the weights as possible. So you can see in this case, the best score goes to the lowest amount of rework, and that's 1,699 pounds in countermeasure 3. So it gets a 5. But 1,784 over there in countermeasure number 1 over here, and countermeasure number 4 has 1,790. They're really close, and they're not too far off the 1,699. So we'll give each of those a 4. Then we got a gap, and we get 1,900 pounds, a couple of hundred pounds more, so that drops down to 2. And then the 2,200 pounds being the most, that gets a 1. And we'll do the same thing for each one. Walking distance, the work in process, and you can see that we've scored the work in process, the 5 units on countermeasure 1, that's like third best. So the best one in that was countermeasure 5. We were able to work with 3 units of work in process. It gets a score of 5. 4 units gets 4. 3 units gets 3, or 5 units gets 3, and then 11 units gets 1. Sometimes you got to get a couple of different people involved to have a little debate about whether you're going to have a 4 or 5. But it really isn't that big of a deal to worry about. Now, if you really want to get precise with your math, go ahead and use the raw numbers. But the weighting itself really kind of makes the algorithm work a little bit better. So we're going to normalize 1 to 5. And you can see countermeasure number 1 has 1, 2, and a bunch of 3 4s and 2 3s. So it's doing pretty good. It's got a high score. You can tell countermeasure number 2 with its 1s and 2s, 1, 3, it's not going to do very well. So you can look at it like this and you can say, ooh, okay, well, this one really looks like it's shaping up to be the best, but we're not done yet. Now we're going to weight the normalized score. So we're going to take the normalized score, the 4, the 2, the 3, and we're going to multiply that times the weight to get the product that goes in the weighted column. And then we add the weighted column to get the total. And of those 5 countermeasures, we take the one with the highest score, and it becomes our recommendation. Now, people being people, we do weird things. So this is a quantitative analysis of these 5 countermeasures using lots of different variables. The math is sound. If you have agreed on the countermeasure evaluation factors, and if you have agreed on the weights and the weights truly reflect the priorities of the company, then you got to stick with this number. And I point this out because I was working with a group on a simple problem. Okay, we had a problem. We wanted to go out to lunch, but we only had an hour. And so the group wanted to decide where to go. And so our countermeasure options were Mexican, pizza, burgers, Italian. So they came up with 4 or 5 options. And the evaluation factors were how fast can we get in and out, quality of the food, what's it going to cost us. But the fast getting in and out was the number one thing. And we ran through all the numbers, and it was clear the winner was going to be going to get pizza joint. We had Mexican. And we didn't follow through with the score because somebody withheld additional information. Turns out they were going to have a pizza party later. So if that had been a factor, we could have eliminated that as a countermeasure earlier. So it helps to get people to really talk more about what is going on in the environment while you're developing the countermeasures and the countermeasure evaluation factors. And here's what it looks like in the world. These were the 5-6 countermeasures that we did for the food company that had the zip tie stuck in the bag. And here's their evaluation matrix. You see, in this case, they got the countermeasures along the left, like the original table, and the evaluation factors across the top. And so they did their math, and countermeasure number 4 won the day. Countermeasure number 4 is to eliminate zip ties. I don't know if they actually got this implemented or not. Okay, next up, we're going to talk about standardized work again. We're going to get back into standardized work and use the work balance sheet to help us do some what-if analysis kinds of things, and then take that next step. So you can actually use standardized work worksheets to evaluate countermeasures.